In this lesson, we're going to learn about permutations and combinations. And the first thing we're going to talk about is this little symbol called a factorial. It's an exclamation point, and it doesn't mean n. It means n times the number right before it, times the number right before it, and all the way down. So an example of this is 5 factorial means 5 times 4 times 3 times 2 times 1. And we multiply that out. You can either multiply it out the long way, or the calculator command is right here, 5 math, and you get to this probability, and it's number 4. So that'll give you that's kind of tricky to get to, but that's how you get to it. And it's 120. So 5 factorial is equal to 120. 3 factorial, which would just be 3 times 2 times 1, we can get to it the same way, is just 6. And then we can just type these into our calculator. 6 factorial. You can keep going back to that probability menu, or if you're really slick, you could grab this and change it. So you arrow up, and when it's highlighted, you hit enter, and that copies and pastes it. So 6 factorial is 720. Now this one says 6 factorial divided by 5 factorial. I'm sorry, 4 factorial. So I'm going to grab a fraction, 6 factorial, and then 4 factorial, and get 30. And then this one, the same thing, a fraction, 15 factorial over 12 factorial times 3 factorial. And we get 455. These factorials have uses when it comes to talking about permutations and combinations. So let's start out by introducing this. It says, suppose 6 runners had entered a race. How many ways can they finish the race? Well, if there's 6 people, there's 6 places that they can finish in. There's first place, second place, third, fourth, fifth, and sixth. So how many people could possibly come in first place? Well, there's 6. Once that place is assigned, how many people are left for second place? There's 5. How many people are left for third place? And I think you see how this works. It's way down. So essentially, the question is 6 factorial, which we've already answered above. So there's the long way, we can figure it out, or if we recognize it as 6 factorial, we can just use our calculator. Now it says there will be an award given for the top 3 placers, first, second, and third. In how many ways can the award be given? Well, how many people could come in first place? 6. How many could come in second place? 5. And how many could come in third place? 4. So we're not going to multiply the 3 times 2 times 1 because we just want the top 3 places. First place, second place, third place. So how many ways could these 6 runners possibly finish the race in those top 3 places and get those awards? 6 times 5 times 5 times 4. 120. Number 2 says, how many ways can a choir of 3 boys and 3 girls be arranged if the boys must sit in the first 3 chairs? So here are the chairs. There are 3 boys. So how many boys could possibly sit in the first chair? There's 3. Once that boy sits down, there's 2 boys left for the next chair, and then the third boy sits in the remaining chair. Now the 3 girls come along. How many girls could sit in this first chair? There's 3, and then 2, and then 1. And we multiply those together. And I think we'll get 36. So there's 36 ways we could arrange those children in some order in those chairs. Now it says 30 people signed up to audition for a talent show. Contestants are called 3 at a time to perform for the judges. In how many ways can the first group of 3 be called? So similar to all of these, how many people are possibly chosen for the first position. There's 30 of them. Once that person's selected, there are 29 left to go in the next position, and then 28 for the next position. And we stop, because we're only choosing 3 at a time. So we just grab our calculator, 30 times 29 times 28. And that's a lot of ways. 24,360. So some of what we just talked about has to do with being a permutation. A permutation is an arrangement of objects where order matters. So for example, if I'm calling, if there's a group of 10 people and I'm just calling 3 people, and here's a silly analogy, as I'm giving each of them a tin can. Does it matter what order I called them in? They're each getting a tin can. If I call them and I'm giving them a gold medal, a silver medal, and a bronze medal, does it matter what order I call them in? Well, absolutely. I want the gold medal. That's the best one. So order matters in a permutation. I think about a pageant. Starts with the letter P. A pageant, order matters, because we all know there's the winner, there's the first runner-up, and second runner-up. So permutation, a pageant, order matters. To get this in our calculator, it's again that probability menu. So we'll do that here. There are 18 people left on American Idol. Only 12 will make the live show. In how many ways can that happen? Well, does order matter on this one? No. So I'm not going to use a permutation. Sorry, that was a bad place to put it. Let's take the previous. Here we go. There are six runners and the top 3 placers. How many ways can the awards be given? So order does matter because we're winning first, second, and third place. So in my calculator, I'm going to call that 6P3. There are 6 people racing, and there are 3 awards given, and order does matter. So it's a permutation. So what I do with my calculator is I'm going to enter 6, and then I'm going to go back to that probability menu. So that's math, probability, I went too far. Probability number 2 is a permutation. So the calculator is going to tell me how many ways this could happen. 6 people, 3 are chosen. I picked 3, and the order matters. It's 120. So that was the same answer I got when I did 6 times 5 times 4. Order mattered, how I picked those. So one of the things we're going to be doing is looking at situations and deciding, did order matter? Did order not matter? So I'm going to jump down to this definition, and then we'll answer the question above. A combination, an arrangement of objects where order doesn't matter. Order does not matter. So this is the situation where I call 3 people up to be auditioned. Did it matter what order I called them in? Not really. I just called 3 people. The silly example again, I'm calling 3 people up and giving each of them a tin can. Does order matter? No. If the first person gets $20 and the second person gets 10 and the third person gets 5, the order I call them in definitely matters. But in this case, combination order doesn't matter. It's on that same menu, and we enter our numbers the same way. We put our total, then we go that math probability is 3, and then we put how many we're choosing. So this one, did order matter? There's 18 people, 12 make it to the live show. They're just a big group. They're a committee. C, for combination, think of a committee. Remember, permutation was pageant. Order mattered. If I'm going to choose a committee, it didn't matter what order I picked them in. So this problem could be written as 18C12. 18, and I'm going to choose 12. The order did not matter. So in my calculator, I'm going to type 18, then go math, probability, and I'm going to choose number 3 because order didn't matter, 12. So there are 18,564 ways we could pick those top 12. Doesn't matter what order I put them in. So as we go through the rest of these questions, we're going to identify, first of all, did order matter, and we'll decide how best to calculate how many ways this event could happen. At Chili's, diners selected 3 out of 5 menu options for a single price. How many different combinations of the 3 menu options are there? So they kind of gave it away here. It says combination. Does it say it mattered what order we got our 3 items in? It doesn't say what order they're in. So it's a combination, 5C3. And we grab our calculator. You could always plug it into the formula, but I have my calculator. So I'm going to go 5, math probability 3. 5 things, I'm going to choose 3 of them. Order didn't matter. There's 10 ways I could order these things. So what we're saying here is if I got loaded fries, a burger, and a lava cake, it doesn't matter if I ate the lava cake first and the burger last. Those 3 items are the same 3 items. Didn't matter which order I got them in. Now this one says, a marching band is divided into squads of 8 musicians. Each squad is required to select a head and an assistant squad leader. If the positions are decided at random, in how many ways can the leaders be chosen? So order did matter this time, didn't it? There's 2 ways I could calculate this one. I could say, well, there's 8 people, so there's 8 I could put for the head leader, and then there's only 7 left for the assistant leader. So I'm going to say 56. If I'm looking at it as a permutation or a combination, it looks like order is going to matter because the first person gets to be the head and the second is the squad leader. So what if I typed in 8, pick 2? 8P2, because there's 8 people, I'm going to pick 2, and order did matter this time. There's 56 ways that could happen. So either of those worked. There are 11 players on the volleyball team, but only 6 can be on the court to start the match. How many different starting lineups are possible? If anyone can play any position, that's important. If anyone can play any position, does order matter? The second question says how many starting lineups are possible if it matters what position you are in. So the first question, anyone can play any position. There's 11 players. I'm only going to choose 6 at a time, and order doesn't matter because anyone can play any position. So 11, math probability 3, 6. There's 462 arrangements I can make if order doesn't matter. Well, what if order does matter? What if it matters which position you're in? Then that's 11 people, and I'm going to pick 6 of them, and order did matter. So we go 11, pick 6. Wow, there's a lot more ways that could happen. 332,640. Because here, we were just in a group of 6. And here, this group of 6 could change. All I have to do is rearrange their order on the court, and that's another possibility. So there are a lot more ways if the order that we're put in does matter. And number 7, there are 8 runners competing in a race. The fastest 3 runners win a ribbon. In how many ways can they finish first, second, and third? Does order matter? Well, I think so, because first place gets a different ribbon than third place. So I've got 8 runners, and only 3 of them are going to win ribbons, and order matters. So I could use this formula, 8 P3, and get 336. Or you might have noticed, well, could I just say 8 people could be first place, 7 people could be second place, and 6 people could be third place? And the answer is yes. So permutations, there's a couple of ways you can think about them, whichever one seems easiest. So you're going to go through these examples, pick out which ones where order matters, like a pageant, you're getting a prize, order matters. A committee is a combination where the order doesn't matter. And there are different ways of calculating both of them.